This orchid has never fed a single insect in its entire life. It produces no nectar, offers no pollen as food, and gives absolutely nothing to the bees that pollinate it. And yet, it has been reproducing successfully across Europe for millions of years, outlasting ice ages, empires, and every other plant that ever shared a meadow with it. What it does instead of feeding its pollinators is considerably more interesting and considerably more cunning. This is Anacamptis Morio, known in English as the green-winged orchid, a name that comes from the distinctive green veins running across the two side petals, which spread out like wings on either side of the hooded flower. It's a small plant, rarely taller than 35 centimeters, easy to walk past without noticing. But look closely and you'll find flowers that range from pure white through every shade of pink and lilac to a purple so deep it's almost black. Sometimes all of these colors growing side by side in the same meadow, from the same species. Its Latin name carries two interesting clues. The genus name Anacamptis comes from a Greek word meaning to bend, a reference to the curved spur at the back of the flower. And Morio is simply the Latin word for clown, which botanists apparently thought suited the flower's extravagant and variable coloration. It is, in other words, the clown orchid. And like a good clown, it turns out to be running a very sophisticated operation beneath the surface. Here is where the story gets genuinely remarkable. The spur of the flower provides no reward whatsoever. Pollination depends entirely on deception, but the specific mechanism that Anacamptis Morio uses is more subtle than simple mimicry of a single species, and scientists have only recently begun to understand exactly how it works. The orchid flowers conspicuously in early spring, and this timing is not accidental. Its main pollinators are queen bumblebees that have only just emerged from hibernation, still slow and disoriented, not yet experienced enough to reliably distinguish a rewarding flower from a fraudulent one. The orchid exploits exactly this window of confusion, but it doesn't simply wait to be mistaken for something else. Research shows that Anacamptis Morio actively benefits from growing alongside nectariferous plants of a similar color. Those plants act as magnets, drawing the right pollinators into the right area and conditioning them to associate that color with food. The orchid then intercepts them, presenting a similar visual signal, but delivering nothing. The flower does produce a scent, but it's too faint to attract pollinators from a distance. The deception is almost entirely visual. And crucially, the scent varies unpredictably between individual plants, so that bees cannot learn to recognize and avoid it. The orchid keeps changing its signature to stay one step ahead of its pollinators. What makes this strategy genuinely clever, rather than just parasitic, is what it achieves beyond simple reproduction. Because pollinators receive no reward, they leave quickly and move further between plants, carrying pollen greater distances than they would if they were lingering over a food source. This promotes genetic diversity across the species. The deception turns out to be evolutionarily superior to honest nectar production. The clown, it seems, is also a strategist. The word orchid itself comes from the Greek word for testicle, because the paired underground tubers of these plants have a distinctly anatomical shape, which the Greeks found impossible to ignore and apparently felt compelled to name accordingly. Greek and Roman physicians, guided by the doctrine that plants resembling body parts could be used to treat those same body parts, made drinks from these tubers and prescribed them as powerful aphrodisiacs. This tradition passed into the medieval world and eventually into the Ottoman Empire, where a hot drink made from ground orchid tubers called salep became enormously popular, consumed the way coffee is consumed today. Salep traveled from the Ottoman world into Europe alongside coffee in the 17th century, and for a time was sold on the streets of London as a warming winter drink. Around 120 orchid species across multiple genera are used to produce salep in Turkey, including species from the Anacamptis genus. The problem is that producing salep requires digging up the tuber, which kills the plant. Turkey has now banned the export of genuine salep powder in an attempt to protect wild orchid populations. But the harvest continues, and the pressure on wild populations remains significant. Anacamptis Morio once grew across European meadows in enormous numbers. a common sight in old grasslands, churchyards, and unimproved pastures from Ireland to Iran. Today, it is disappearing, and the reason is one of those cases where a perfectly ordinary human decision turns out to have consequences nobody anticipated. Agricultural intensification, and specifically the application of nitrogen fertilizer to species-rich grassland, has been identified as the principal cause of the orchid's decline across Britain and Ireland. The orchid evolved over millions of years in poor, thin soil where competition from larger plants was limited. When farmers began fertilizing meadows to increase grass yield, the tall, vigorous grasses that responded to the extra nutrients simply grew over and shaded out the orchid. One routine agricultural decision, repeated across thousands of farms, quietly eliminated this plant from most of its historical range. But there's a second problem that makes recovery extraordinarily difficult. The seeds of this orchid are so tiny that they contain almost no nutritional reserves. They cannot germinate without a specific mycorrhizal fungus in the soil, which provides the nutrients the seedling needs in its first weeks of life. Pesticides and fungicides disrupt the soil fungi, so even in places where the orchid manages to flower and set seed, the next generation cannot establish itself. And because the plant cannot self-pollinate, it is entirely dependent on bumblebees to reproduce. As bumblebee populations decline, orchid populations follow. It is, in other words, a plant that requires everything to go right simultaneously. The right soil chemistry, the right fungal partners, the right pollinators, and the right management of the land around it. Remove any one of these, and the whole system fails. This orchid has been running the same elegant confidence trick on bumblebees for millions of years. It survived every ice age that reshaped the European landscape, outlasted every civilization that ground its relatives into aphrodisiac powder, and refined its deceptive strategy to the point where scientists studying it still argue about exactly how it works. And now it is disappearing from meadows it has grown in since before humans existed, not because of anything dramatic, such as a disease, a predator, or a catastrophic event, but because we started putting fertilizer on the grass and cutting it earlier in the year. A clown that outwitted evolution for millions of years, undone by agronomy in 50. If you walk past a meadow this spring and see small purple flowers nodding in the wind, it's worth stopping. You might be looking at one of the most sophisticated deceivers in the natural world, a plant that has never given anything away in its life and has thrived precisely because of it.